Okay, so this is number 28 from Chapter 4. The problem says, an object of mass 2 kilograms starts from rest and slides down an inclined plane 80 centimeters long in 0.5 seconds. What net force is acting on the object along the incline? So here's my diagram. Here's our 2 kilogram object moving in this direction. This is the force of gravity. This is the normal force. And we're given that the incline is 80 centimeters long. The time it takes is 0.5 seconds, and that the initial velocity is 0 because it starts from rest. Here's my coordinate system. The x-axis is going to be in this direction because it needs to be parallel to the incline and the direction of movement, and then the y-axis is perpendicular to that. So we want to find the net force along the incline, which essentially means the sum of the forces in the x direction, since the incline is parallel to the x-axis. And we're going to use Newton's law, which means that the sum of the forces causes the mass to accelerate. In order to solve for the sum of the forces, we need to find acceleration, and we can do this using the kinematic. Delta x equals velocity initial times time plus 1/2 at squared. First, we need to convert 80 centimeters, which is equal to 0.8 meters. Set that equal to 1/2 at squared. And this term becomes 0 since the velocity initial is 0. And if we continue to solve for a, we're going to get 6.4 meters per second squared. Now we can plug in a into Newton's law to find the sum of the forces. Now we have the sum of the forces equals the mass, which is 2 kilograms, times the acceleration, 6.4 meters per second squared. We plug that into our calculator and we'll get the sum of the forces equals 12.8 newtons, where the book says 13 newtons.